Hi everyone. So today is the last seminar before the presentation. And so these are the things that we are going to talk about today. So first is about the mandatory presentations. And the second is about the simultaneous causality. So the thing that we didn't stress that much um, in the previous seminars. And the third one is like some review about F-test, but I think you already knew what F-test is. And the fourth one is talking about like some operations in data. So for example, how you can deal with the logarithm and zero values. And the other one is about like how to create the statistic tables by data. And the fifth one is about the panel data and fixed effects. So how you deal with the panel data in Stata. So yeah, so let's start the first one. And before the first one, so I'm going to talk about the assignment 4. So I think, yeah, so I just finished the grading on Wednesday, and I think most of you can take a look at the comments. So basically, I think everyone did it quite well, but just some people, maybe they don't understand what's the like some people they didn't finish the like question 3. So so some people they didn't write the answer for question 3, so the Frisch-Wolf theorem. So maybe you can go to take a look at the textbook. So what does it mean by Frisch-Wolf theorem? And if you have any question after you read a textbook, you can come to ask me. Yeah, but I mean it's like but I think most of people still did it quite well and quite good. And yeah, so now let's start the today's like session. So the first one is like term paper presentations. So basically you need to hold a 6-minute presentation of your term paper. So your presentation should include like what is your topic, so what is your research question, and short motivation, so why you do it, and then how you will do it. So what is your main regression? So what is your variable of interest, and like which variable will you use in your regression? For example, like the independent variables, and also like your preliminary results. So how far have you done until like May 15th? So it's like until next Friday. And then the suggestion is that you can use slides or like the whiteboard. So I think on that day, I'm still not sure like how it will go next week, like next Friday, like how the presentation will go. So probably we will combine like 6 group into one session of seminar and directly do it. But yeah, so it's still not sure, and I think I will discuss with my partner and also like the lecturer about how to do the presentation next week. Yes. And so basically, you don't need to take you don't need to um, you don't need to be too nervous or worried about the presentation. So basically, what you need to say in the presentation is like 3 things. So the first one is what are you going to do? And no, so the first one is what do you want to do? So your topic. And the second is what are you going to do? So how will you do it? And then third thing is what have you done these days? So basically these 3 things. So you don't need to finish all the paper on that day, but it's just like you talk about like what's your current progress and what's the question or the problem that you just met during these days. So since the problems that you will encounter are most likely similar, so during that day, you can like take notes of feedback. So to see like maybe the people um, have the same. So maybe you have the like you face a similar questions as like others. Yes. So yeah, so basically there are some criterias for term paper. So the first one is like independently carry out an empirical project. So yeah, so this is quite self-evident. And the second is that explain and interpret the results of regression analysis. So I think this is the most important thing. So not only you need to have a result, like a statistical result, but you need to know how to interpret the result. So the interpretation is the most important part in the term paper, I think. And then the third thing is that there's no like perfect um, empirical studies. So you need to know what's your strength and what's your weakness and what's your limitation in your regression analysis. So if you want to know more details about how we grade the paper, you can take a look um, about the introduction of term paper. So on Athena, I think you can check it. Yeah. And I think on Athena there are some past papers as well. So if you think those papers are not clear enough, you can ask me, and I will send you like more papers if you want. Yes. So there are two two other things that I would like to emphasize. So the first one is that, yeah, I think it's the, how's it called? Statistics 101. So correlation does not imply causation. So so you cannot directly interpret two variables have a causal relationship just because they are correlated. And the second thing is just because you have significant coefficient for your main variable of interest does not imply that you are done. So probably your research or your regression suffer serious omitted variable bias. So the significant coefficient may be just because of bias. So these two things are the things that I would like you to always keep in mind when you write a term paper. So yes, so the deadline for the term paper is May 13 at 4 p.m. So the reason that why we set this deadline is to give me and my partner some time to read your term paper so that we can give out some comments like even before your presentation. And then you should focus on the text, not the do file. So you don't need to upload the data set and the do file in the first draft. So it's only about the text. And yes, make sure to upload it before the deadline so that we can take a look about what you write, what you have written these days. Yeah. And yeah, so this is about the term paper. So if you have any further questions about your topic, yeah, just feel free to email me, or like if you would like to like talk directly to me, you can also email me and set like Zoom meeting with me. So it's also fine. And because some people are asking me about, like some people ask me about the possible sources of data sets. And so on Athena, I already uploaded some websites. I think it's about 4 or 5 websites. So like for you to find the data source, yeah. So I think those websites are like they are, I mean, yeah. So I mean like I think this is my limit of ability. So they are already the data that I can find like as much as possible. Because the data system is not that open, so it's quite closed system because it's not free and not public. So there are not so many data sets for Stata to use. I mean like public. There are not so many like public release data for Stata to use. So those data sets are, I think, the data set that I can found like until now. So if like before the deadline of preliminary version, if I find more data source, I will keep uploading them like on Athena. So for you to think about what you can do. Yeah, so by the way, for the presentation, so if you still cannot come up anything until that date, um, I think you can still, I think you can just say that you don't really know what to do. It's fine. But of course, like you like it's of course like worse than like if you like get full prepared. But I mean if you really like if you really cannot come up with anything, um I mean like it's it can happen as well. So I mean like just don't be too nervous and too worried about the presentation. Yeah, so it's just about the current progress. Yes. Yeah, so let's enter the second session. So it's called like simultaneous causality. So I think I somehow explained it before. And yeah, so this slides just illustrate the simultaneous causality with the like one of the most classic examples. So it's that a policymaker wants to know the effect of adding police officers to an area on the crime rate in that particular area. So what do you think this effect will be if we estimate this regression not using experimental data? So the problem is that, so as we know that, like when there are more police like in one area, so the crime rate will decrease. But at the same time, if there are higher crime rates, so the policymaker would like to put the police officer to that area to decrease the crime rate. So if you're directly using the observational data instead of experimental data, so you will find that maybe the coefficient beta 1 will be positive. So if there is like bigger police size, then the crime rate will be higher. But of course, like this beta will suffer quite serious bias of reverse causality. So this is the data set that we use to illustrate this situation. So I also upload this data set called crime. Yeah, so it's so this data set is one of the data set in the website that I upload on Athena. So the original name is called Cromwell. Yeah, but we call it crime here. So it's a panel data set to estimate our model of interest. So you can see that actually the coefficient is like positive. So it means that if there is a bigger police size, then the crime rate in that area will be higher. So actually it's a bit unreasonable. But just as I said, so this coefficient suffer quite serious omitted variable bias. So you you cannot make a causal interpretation from these results. So the problem to mitigate the simultaneous causality bias, so it's not that easy to use just like control variable, because the control variable is to mitigate the omitted variable bias, but the control variable is like they cannot eliminate the bias from the simultaneous causality. The reason is that because this bias is from the main variable of interest and the dependent variable. So it's only between like these two variables. So it's not related to any omitted variable bias. So even if you add as much as even you add as much as control variables as you cannot still like eliminate it, like or reduce this bias at all. Yeah. So yeah, so this is about the simultaneous causality. So yeah, but for like omitted variable bias, you can still try to add control variables to mitigate it. So for example, in this data set, so we add regional dummies to control for the like factors related by regions. And then also add the control variable for population densities. So I think like you already learned this before. So like how to create the dummy variables from the categoric. So one thing that you need to keep in mind is that since now the region is defined by the words, so the categorical variable that we met before is like, for example, if you are in primary school, then it's 1, and if you are in like junior high school, it's 2, and then if you are in high school, then it's classified 3. But here, since the region is classified by words, so west, central, and other, so they are called string. So if you would like to create a dummy variable from a string, you need to put the like double quotation mark in front of like in the specification, so you can see that. So there are like double quotation here. So this is the only difference between the string and like between so this is the only difference of how to create a dummy variable between string and like numerical like categorical variables. So as we can see that, so yeah, so the effects of police per capita on crime rate have increased from approximate like 1.2 to 1.5. Yeah, so and the significance level even increases. Well, yeah, so let me check. Oh no, so it's decreased. Yeah, yes. Sorry. Yeah, so the significance level decreased, though it's still like higher than like so I mean so the t value is still larger than critical value like of 5% significance level. But like even with this, so you cannot still make a causal interpretation of these results. So just as what I said, so the control variable can only control for the omitted variable bias, but it cannot really break the bias from the reverse causality. So even, for example, you control the bias related to regional difference, but you still cannot mitigate the bias from the crime rate to police. So you cannot really break this like reverse causality. Yeah, so this is what I would like to say about the simultaneous causality. So I would say that if your topic is related to simultaneous causality, so you shouldn't put too much expectation in really solving the causality problem, because even if you put as much as control variable as you can, so you can never say that you really get the true causal effect. Yes. And this is F-test. So I think you are also familiar with F-test. So yeah, so I would like to just kind of skip it because I think you know how to really do the F-test. And yeah, so and then now it's about like stata. So it's like about how to handle logarithm and zero values. So for example, if your topic is about wage, so we usually put a log in wage to make our dependent variables becomes more normal distribution. But the problem for log is that log cannot handle the negative values. So the values inside log must be positive, and also which also means that zero cannot be put inside a log as well. So for example, when you put wage, if someone is unemployment, so they will have no wage. So as a result, they will have zero wages. So which means that if you put logarithm in it, then it will become like error. Um, yeah, so so actually there's no clear way on how to handle this. So so the most easiest way, like the easiest way to handle the zero values is to drop them if they didn't like account too much in your data set. Another simple way is that you shift the distribution by one. So for example, if your original wage is zero, then you put like 0 plus 1 and then put the logarithm. So you shift the whole distribution by 1. So what's the advantage for this? So now like the zero wage becomes like wage 1. So if you put logarithm, like log 1 equals to 0. So it will directly avoid the zero value problem. Yeah, so I think like how to drop it and how to generate the new like variable with like log weight plus 1. I think you also know how to do it. Yeah, so this is just like reminder. And then now it's about like how to create like tables by using stata. So after you run like many regression tables, you would like to create as like statistic tables to show your results. So one way is that you can directly create a table by Word or Excel, and then like copy them and then put them in the Word. So it's one way. And the other way that you can also create the table by Stata. So you need to use a package called ststore and also called like stab. So you need to install those packages first. And then the way that you do it is that so for example, you want to create a tables to record these two regressions. So the first one is the simple model. So it's like log wage with high school and university. And the second is log wage with high school, university, female, public experience, experience square, and also two other interaction terms. So after you run these two, so the first one is that since those variable names is not really the full name of the thing that you would like to represent. So for example, like experience is called like expr in the regression. So you want to change it. So the way that you change the name is to use a label. So it's called label command. So like you put label variable like expr. So expr is a variable that you put in the regression, and you want to give a new name for them. So you put a string like experience here. And then you use like store clear. So to clear the previous statistics stored. And then you use store again. So this one is the one that you want to create a summary statistics tables. So the previous one is the regression, and now the first one is about the summary statistics. So for example, if you want to create a table to record, for example, like what's the minimum, what's the maximum, what's the average value, what's the standard deviation for those variables. So you can use this one. So you use as store, and then you just put the summarize comment here, and then put these 4 variables that you would like to summarize, and then just follow this order. So you use as tab, and like using table 1 RTF. So this is the file that record the table that you would like to put in, and then so like the SD is for like standard deviation, the mean is for the minimum, and label mean is like to put mean in the front, and then also the maximum. So you can also adjust for like titles, what you want to put. So by like putting these comments in the S tab, so you can adjust the format that you want in the statistic tables. And then after you do this, so this will become the table that you would like to present. So I will put the document from Stata, and you can follow it to see like what other adjustment that you can do with this step. And yeah, so if you have a binary variable as your independent variable, so you can also do a table to present the shares of binary variables and means of contributing variables by the groups of your independent variable. So it's like so it's all by your like choice. So you can put the thing that you want to present in the like summary statistic tables. And yeah. So that one is about the like summary statistic tables. And to present the regression tables, I will upload the do file, so you can follow like and also like imitate the format in the do file to see like how to create the regression tables. But yeah, and I will also upload the I will also upload the Stata documents to explain this like further. So basically, to use like Stata to create a statistic tables, you always use the package called as store and also as tab. So to add things that you would like to put. Yeah, but of course, if you think that these things are just too complicated, the most like the easiest way to do it is actually to just how's it called? To just do it like by hand, like by using Excel and also words. If you don't have too many regressions, and also you don't have too many variables. So actually, like I think if you directly type it by Excel and Word, actually maybe they are much faster than using a Stata. Yeah. So this is another, like, it's just like a recommendation, like just like propose another way of doing the same thing. Yeah. So now like there comes the last part. So it's kind of like a reminder about panel data and fixed effect. So it's talking about how to do the panel data and fixed effect in Stata. So we will use the crime DTA. We will illustrate it by using the same data set as in the second session. So fixed effect regression is a method to controlling for omitted variable bias in panel data. So when the omitted variables vary across entities but do not change over time. So for example, the regional difference. So we think that there are some bias, some omitted variable bias, like related to the region, but they are stay the same and do not change over time. So yeah, so this is what fixed effects try to fix. And so yeah, so the observations in the panel data are between entities across time and an alternative to regional dummies. So what we fixed before is that we add west, central, and also what's it called? We add west, central, and other. But actually, like they are like even more finer level, like different counties. So we would like to control the bias related to counties. So a common way to denote entity fixed effect is here. So it's called alpha I here. So alpha I stands for the like the bias related to region, but do not change over time. So you can see here that so there is some like details in the specification in the regression. So here police is like IT. So I stands for like the place and T stands for time. So you can see the alpha I here does not have any like T like time. So there is no time variation in this bias, like in this like fixed effect, because it only stands for like regional fixed effect. So there are several ways to include fixed effects in the regression using data. So one is by using the XI column. So you just put it before like regression, and you define the time and entity fixed effect as like I dot like variable name. So they will create multi-binary variables. So they will create the county dummies in the regression. So for example, now we want to control for the bias related to county. So which means that here the dummies is county. So we put xi colon here and then regress I dot county and then run a regression. So this is the first way. And the second way is that, so maybe there will be lots of dummies. So instead of create lots of dummies in the data set, so we can directly absorb the data set. So we can directly absorb the fixed effects of counting. So another way is using array. So the first one is xi colon, and then create lots of dummies. And the second way is use absorb. So you use absorb regression, and then you put a comma here, and then absorb county, and then this stands for like robust. So it's the same as here. So this is the second way. And then the third way is to use xt set and also xt reg. So it's also another way to run the fixed effect regression in Stata. So these actually are the same. Yeah, so they are like 3 different ways to do the same thing. And then, so for example, not only there is bias related to region, but of course there are also bias related to time. So for example, like every year the crime rate is different because maybe like in the first year there's some special events which cause the crime rate in that year suddenly increase. So you would like to also like control the bias related to time. So then you would like to put the control variable which control for time. So just as the region. So it's yeah, so we now you can see here we put time fixed effect here. So it's only like variation over time, but not like region. Yeah. So it's actually the same as what you did before, like what we just talked a few minutes ago. So in addition to I counting, now you have I dot year. Yeah, and then you can also combine the xi command with areg and sreg. So absorb county, but you can create the like year dummies by using xi. Yeah. So these are like some tactics to run the fixed effect regression if you in Stata. Yeah. So this is what I would like to say in this seminar. So if you have any further questions, feel free to email me. And I hope you get something from like these seminars, like this period. So, I mean, it's also the first time for me to do a seminar like this. So I hope that I really helped you something and didn't confuse you, or like I really help you to learn like statistics and also econometrics. So this is what I hope. So yeah, so if you have any questions or you think there's anything that I can improve or I can help you, so always feel free to email me and I would like to help you because this is my responsibility as well. So anyway, I hope you yeah, I hope you didn't lose the interest in econometrics because of me. And I hope that you really learned something from econometrics. Yeah, so thank you very much. And for the further information about the presentation next week, I think I will upload what's the result of discussion. Yeah, next week. So this is our seminar. See you and good luck for your presentation next week.